So I'm now going to welcome Marc Keuschnigg. He's Associate Professor in Analytical Sociology at the Institute for Analytical Sociology in Linköping, University, Sweden. And it's going to be talking about analytical sociology, presenting what it is, and how it may be kind of benefit from computational social science approaches. Thank you very much, Marc, and over to you.
So thank you very much for inviting me to give this talk on the relationship between analytical sociology and computational social science and how both fields benefit from each other to provide explanations of social phenomena. And I assume you all see my slides, right? So I guess this talk connects quite nicely to what we just learned from Gary. And as a starter, I want to present some, let's call it meta-theoretical thoughts that are foundational to analytical sociology. And analytical sociologists aim at explaining macro-level social outcomes, such as segregation, the diffusion of products or behaviors, or specific network structures, explaining such social outcomes on the aggregate level by reference to the actual causal processes, which we like to call generative mechanisms that bring them about. So we prioritize realism over stuff like instrumental explanations. And this is a core principle of analytical sociology. And in trying to do so, we acknowledge that aggregate data alone says very little about generative mechanisms. We just heard a similar thought by Gary. And at the same time, we also acknowledge that individual data alone, say from surveys, rarely explain macro-level outcomes. So to understand the dynamics that generate many macro-level facts, we aim at linking the micro and the macro, and we take into account that individuals are embedded in social environments and that they react to each other. And particularly this reacting to each other, of course, can give rise to complex dynamics, which we as analytical sociologists aim at explaining. But until recently, sociologists lacked the data and the tools to analyze large and interconnected populations and their dynamics. And microdata, particularly with the rise of large-scale survey data collection starting in the 1950s, microdata came to dominate our discipline. Also, the statistical tools we started to use, so developed to analyze independent data points or individuals. So I'm mainly referring to regression analysis here. So we had a focus on individualized data points, our survey respondents, and as a consequence of this, we started to see a shift from analyzing system behavior to analyzing the socio-demographic correlates of individual behavior. And with the onset, what sometimes is called the data science revolution, new data sources and new tools have become available. Data sources such as observational data on large network populations, but also experimental data from large-scale web experiments, and new tools such as simulation, as we just saw, machine learning, and here in particular text analysis, which are more and more fruitfully used in sociology also. And the interesting fact here is that these new data sources and analytical tools provide an excellent fit with the core questions of classical sociology, which has been interested in the social dynamics in networked societies. And this allowed incorporating these data sources and tools allows us now for us sociologists to change the focus to populations of interacting individuals. And the intake of bigger data and CSS tools allows for, one could say, for a more social science. And together with colleagues, I have argued that this incorporation of CSS tools could be as relevant for advancing sociology as the introduction of econometrics has been for economics some 80 years ago. So I'm full of praise for CSS here, as you can see, but of course, the relationship between analytical sociology and computational social science is not a one-way street. And both fields differ considerably when it comes to their explanatory ambitions. And here we see the main contribution of analytical sociology to this intersection between the fields. And when I go to CSS conferences, I often hear statements like this. I'm showing here, although the signal is noisy, we find a universal pattern. So description of aggregate data is still a core activity in the CSS community. And often computational social scientists engage in describing these aggregate patterns, and some even label them as social laws. Power laws are a prominent example, and often they have been interpreted as an indication that similar mechanisms are at work in different social domains. And but we as analytical sociologists want to stress that, of course, discriminating between generative mechanisms becomes impossible as soon as you have different competing mechanisms that might lead to the same aggregate patterns. And I brought one example to illustrate this point and to illustrate the gap between description and explanation. And many of you will be familiar with the field of urban scaling. So the basic idea is if you increase the size of a city by 100%, you typically observe an increase of urban output, not by 100%, but by more. And often this is 115% more. So you observe this magical plus 15% in aggregate output of cities. And you find these magical plus 15% for various urban indicators, such as GDP, income, and patents, but also for negative city things, such as crime or infectious disease. And this seemingly robust finding has culminated into a very provocative quote by Geoffrey West, one of the leading figures of the field. And he says, you could just take the same person and move this person to a city that is twice as big, and suddenly this person will produce 15% more of everything we can measure. And the common explanation for this phenomenon in the CSS community is that that increased social interconnectivity in dense urban environments allows for agglomeration effects and produces this superlinearity in the association between city size and urban output. But as we all know, city populations also differ in their composition. And when you look at bigger cities, you also find, for example, more college graduates as a fraction of city population, or more people who work in high-yielding creative jobs, as illustrated in this in the left plot here. And based on individual data, which we connect with the aggregate data that urban scaling researchers usually build on their research, when we connect these two data sources from two levels, we can clearly see that the population composition of cities explains around half of the superlinearity reported in earlier work. And a main driver here is the selective migration of promising people from the countryside, as we see in the right side map, to the biggest cities. We are using Swedish register data here, and you can see marked differences in population density across Sweden, and we see strong selective migration from the countryside into the biggest cities. And we can also see that these people who move from the countryside to live in cities have more education on average than those who stay behind, and they're also smarter in terms of cognitive ability or IQ when those who move to the bigger cities. So those internal migrants crucially add to cities' productivity, contributing to these magical plus 15%. We can also see, using microdata, that urban indicators have a strong right skew within cities. They're heavy-tailed within cities, and the effects of interconnectivity, of productivity and innovation, they mainly work and manifest in the heavy tails of cities. So one could say that between city scaling rests to 30 to 60% on within city tails. And this means that an all boats will rise interpretation of agglomeration effects is premature, and we see strong levels of inequality driving superlinearity and also growing from superlinearity. So this example shows that a more nuanced analysis of aggregate data by connecting micro-level data more seriously points to the generative mechanisms behind agglomeration effects. So besides description, prediction, of course, is a core activity in the CSS community, and many analytical sociologists are much less concerned with the applied predictive uses of CSS tools, some of which have been proven highly relevant this year in particular. But still, of course, because many of those predictions directly translate into powerful policy recommendations, some have also called for an end of theory. Why do we still need theory if we can run our algorithms to recognize patterns in our data, for example? And of course, we as sociologists, we don't buy this argument. And most of these powerful policy recommendations, they relate to the physical world, to medicine, to infrastructure, for example, where we know quite well how things work. In the social world, on the other side, we might be able to predict things like stock market shifts or political instability by looking, say, at social media posts. But our knowledge of these social systems is still so poor that we don't know the intervention points to turn such predictions into relevant policy recommendations. And in this talk here, I want to call attention to the theory-driven approach as represented, for example, by analytical sociology, and which helps to identify the generative mechanisms of social phenomena in order to isolate crucial intervention points in poorly understood social systems. So I leave the remaining minutes for discussion, and thank you all for your attention.
Thank you very much, Mark. I know that you have to go to pick up your kids, so I'm not going to hold you up for too long. And if we have some time, we can then maybe have another question for Gary, which appeared on Slido. I don't see immediate question to you, Mark, at the moment on Slido, or no one has raised their hand, so that's why I'm going to ask you a question. Can you maybe reflect generally what the analytical sociology approach could offer, maybe specifically to the landscape decision making, and like the kind of the problems that they're facing? So as you know, this kind of whole workshop is about kind of integrating social science approaches to the landscape decision making, to kind of have a better understanding of how actually humans make decisions, so that better decisions can be taken in terms of like what landscapes should be preferred, or like which policies should be implemented. So maybe you can briefly reflect on that as well. Thank you.
So I think a crucial element that analytical sociologists are sporting when it comes to agent-based models, as we just saw in Gary's talk, would be to take pains and really invest a lot of work in empirically calibrating agent-based simulations by using real-world data, be it online or registered data, or even from social experiments, to make sure that the micro-level rules that you impose on your agents are validated from the real world.
Thank you very much. There's now a question from Yandik. He is asking, do you think the increased connectivity occurring in rural environment, so the internet, social media, may reduce the 15% urban effect you show?
Yeah, this has been, this question has appeared about 10, 20 years ago in urban economics, where people ask, why do cities still exist now that we can interact online and could basically live anywhere as we do right now? And this is an ongoing puzzle, but it seems that we do need face-to-face interactions to be spontaneously innovative over longer periods of time. And I guess we all start to feel it, since we have been in home office for so many months, that it's not a full substitute to be interacting online, and that coming together in a huge container that a city is, that forces us to interact and also enable spontaneous unplanned interactions, is still important for this social interconnectivity argument to work out.
Okay, thank you very much, Mark. There's now a question from Felix to you, Mark. Felix says, I would argue that the analytical sociology approach is exactly what the landscape decision approach requires as well, as we also do not understand the mechanisms and need to. So that's to be more like a comment. Then Darren Evans says, have you considered how changes in social network structure affect ecological network structures and vice versa?
I have to admit, I'm a sociologist. I'm not too familiar with these terms, so perhaps you could give another pointer or rephrase your question.
Darren, maybe you want to raise your hand and ask the question again. Meanwhile, Rihanna is asking, does the 15% urban effect just mean an increase in productivity, or does it take into account quality?
It means both. So it depends on the indicator we use to measure these effects. So if you look at urban GDP, it's mainly about just productivity. But if you look at innovation, for example, patents or research grants awarded to people living in different cities, then it also measures quality. And we see these magic plus 15%, we see them regardless of whether we just take a quantity-based indicator or a quality-based indicator.
Darren, you can now ask your question live, please.
Thank you. Thanks, Mark, for a nice talk. I guess a lot of the stuff that you were describing in your talk in terms of scaling laws and looking at the interconnectedness, for example, of people's friendship groups and so on within cities is very similar to the way ecologists study how species interact. Mm-hmm. And they're all based on graph theory. So if we have information on the species and how they interact, or on people and how they interact, I was just wondering whether you have explored how you could merge those sorts of frameworks. So how the change of an ecological network, which may sort of reduce the ecosystem services, if you like, provided by a rural area, may impact upon the structure of the social network, and vice versa.
So this is an interesting avenue to follow, and we have not yet looked into that. And but what would be your dependent variable? What kind of urban indicators or rural indicators would you look at?
I guess that's part of the challenge, is to find a currency, really, which might make sense. For example, you can imagine how, if you have modeled the how species within a woodland or a forest interact, for example, well, that forest is managed in some way, either for amenity woodland or for commercial purposes. But what if that woodland was impacted by a new disease, for example? How would the change in the functioning of that forest impact upon the social interactions in terms of the decision making of how that forest is managed? So it hasn't answered your question in terms of what specific metric might you use, but that I think would be quite interesting to pursue.
Okay, thank you very much for this comment.
Okay, so I have another raised hand from Felix Einbert. Felix, please.
Oh, hi, Victoria. I just thought it might be, I found both the last talks really interesting. And I was just, I guess this is more of a comment. So I tried putting them on Slido, but perhaps it's more relevant as a comment. And well, I suppose what I was saying was that it was fascinating, especially I found Mark's talk particularly interesting, this sort of the pattern compute sort of, I guess, ML approaches and sort of big data approaches. I think you also see it sort of in the more ecological community, and this more hypothesis-driven approach, which this sounds like is what analytical sociology is more taking. And again, I agree. I think it's really relevant for landscape systems, because I think, well, if you're talking about analytical sociology, you're dealing with the human system. For landscape decisions, we're dealing with an integrated socio-ecological system. I would argue is even more complicated, even less understood. So I think quite possibly the need to really think about where the analytical sociology community is going and how they're trying to link these data sets to really come up with some robust theory, I think is potentially really useful, also for making our models more tractable. And again, I'd be very interested to hear what Gary thinks about that, about how, whether that's the wrong way around, or I mean, to my mind, it makes a lot of sense to go as far as you can to make the system as simple as possible based on your theory, and then try to build your model. But I guess one could argue that if you don't understand the system, there's a lot to be gained by playing around with lots of stuff at the same time. I'd just be curious to hear comments from possibly both of you, but particularly Gary. Thanks.
Okay. So yeah, I think you asked a very interesting question. This point about trying to simplify things first is well made, because as I said, there's this big risk that if you shove everything in, you end up with a model that's probably buggy and has got more difficult to understand almost than the real world, even though the real world is itself extremely complicated and complex. However, I suppose what I would say is that that should be done with an eye on the possibility that your simplification could be ignoring something you might later find to have been important, and or well, as I was saying, you know, your conceptualization of the system itself, however you simplify it, could be embedding. I'm sounding like a sociologist, crying out loud. It could be embedding, you know, political disadvantage that you're not really intending to do. I'm assuming one wouldn't want to do. So I would say a sort of a cautious yes. You should be looking, you know, you need to have some kind of rational or reasonable way in which you're going to model the system and try and check that it, you know, that it makes sense. And I suppose that's why I was raising this question of how you might validate ontologies. I did have a paper in JAS with a rural sociologist colleague of mine, where she actually went back and took some of the key assumptions that we'd made in the model about how farmers made decisions to key informants in the system. So I suppose this would come down to, you know, transdisciplinary methodology and so forth. So yeah, and caveats around oversimplification in case you're missing something that may later prove to be important.
Thank you.
Maybe just to add, I mean, obviously, if the system involves actually humans and human decision making, so we cannot simplify over those processes, because this will probably hand back the system if we don't understand how exactly humans make decisions, how they interact when they're making decisions. So I suppose, and I think that's like where we usually really do analytical sociology and HBS modeling can really help a lot to understand those mechanisms. I would like to thank very much Marc and Gary for your really good talks to kind of kick in, to kind of really get started the sociological or social science kind of perspectives on those questions and how they can contribute to landscape decision making and solving landscape decision making problems. We will now go into the lunch break, and after lunch, so at 1:30 we will be back, and then Felix will be sharing the other talks on social modeling. Thank you very much, and I'll see you later.
Thank you very much.
Bye.
Thank you. See you later.
See you. Bye-bye.